Today we're going to talk about pragmatism. Pragmatism is one philosophical view that is thoroughly American in its orientation. In fact, most people think of American philosophy and immediately think of pragmatism. And there was a period in the late 19th century and early 20th century when the pragmatists really dominated American philosophy. There were other groups, to be sure. There were some realists, there were some personalists, some monists, and so on. But the pragmatists had a strong lock on most very good American philosophy departments, and that really became a symbol of American philosophy. These days, pragmatism is in a little bit of a retreat in the sense that figures like Peirce, James, and Dewey, who were the key figures in that early movement, no longer have quite the same level of respect. But nevertheless, their attitudes and their perspective continues to be highly influential, not just in the United States, but throughout the English-speaking world at least, and increasingly has an impact on French and German philosophy too. So pragmatism remains a very appealing philosophy to many people, a very powerful philosophy that, whatever one ends up thinking about it, needs to be addressed and dealt with. In the United States, it was formulated, at first, by Charles Sanders Peirce. Peirce had an odd academic career. He hung around Harvard for much of his academic life. Though he never really was hired there as a professor, he had various subsidiary positions. He was himself trained as a scientist at Johns Hopkins and ended up living most of his life in a large house in rural Pennsylvania, not too far from the Delaware River, and in other words, just across the river from New Jersey. Well, he developed something known as the pragmatic theory of truth. He didn't like the fact that his principle of pragmatism became so popular that other thinkers began to use it and actually, in his view, misuse it. He changed the name of his view to Pragmatism because he thought it was ugly enough that no one would try to copy it. Luckily for us, that did not really stick, and so his view is still known as pragmatism. Here is the key idea behind it. The principle of pragmatism says there is no difference in meaning without a difference in practice. So what really matters is what difference it makes. Indeed, we sometimes talk about things and think about a discussion that somebody's having and say, well, what difference does it make? And that's exactly Peirce's question. He says we should be asking that about everything. Let's say two people are debating a question in theology about the nature of God. One person says, I think God is absolutely simple. All the properties of God end up being identical. The other person says, I don't think that's true. I don't think this idea of the simplicity of God makes any sense. Peirce says, what difference does it make? Okay, what difference does it make to your actual practice? In this case, the way you live your life or the way you live your religious life? Does it make a difference in how you worship? Does it make a difference in what you do in any respect? If not, there's no difference, okay? Ignore it. It's a meaningless dispute. Don't waste your time. And some pragmatists put it in a very strong form, saying, look, then there is no difference in meaning. The issue is utterly meaningless. You're not talking about anything at all. Others say, well, maybe you are. You're wasting your time, though. There's no point in discussing it. It makes no difference. And so as he means it, it really is the stronger version. There is no difference in meaning. Of course, it doesn't just happen in theology. It can happen all over the place, in philosophy, in politics. You can say, well, in the end, what does it matter? What do we do differently if this is true? And if the answer is nothing, stop fighting about it. This dispute doesn't really mean anything. It's not really about anything. So his idea is that meaning depends entirely on practice. And pragmatists are fond of using the phrase, the cash value of something. What he means by talking about the cash value of a view or the cash value of a proposition is simply this, the difference it would make in practice. To get clear about the meanings of our terms and our thoughts, we need to be clear about their practical antecedents and their practical effects. What would, practically speaking, make somebody say that? And what difference would it make if they were true? What would the effect of that view be? All too often, he says, we look around and we find out nothing. People are fighting about nothing. They're arguing about an issue, and in the end you say, I don't understand why it makes a difference. Now, we've got to be careful here, because sometimes it makes a difference of a kind, but no difference to what we might do now. Suppose two people are historians and they're fighting about the details of what happened during the 14th century. Well, are they really involved in a meaningless discussion? Presumably not, even though you and I would say, well, I'm not going to live any differently, depending on what exactly you decide happened in the 1340s. But there is a difference about what they're going to teach, for example, what they're going to write. And so we don't want to say about all of history, forget it, it doesn't make any difference, or at least, if it's not immediately relevant to our present situation, it doesn't make any difference, so history is meaningless. We certainly don't want to say that. So we've got to be cautious here and understand difference in practice in a very broad sense. But there are still issues that you might say, I don't see how even the historian or even the astronomer or whatever is going to really do anything differently as a result of all of this. And he thinks that happens fairly frequently. Much more frequent, however, is the idea that we're fighting about something, arguing about something, and we aren't identifying the real issue. We think the issue is this, but really when you analyze it and say, what difference would it make in practice? You realize, oh, it's really this. And that kind of thing does happen all the time in everyday life, as well as in academic contexts or political contexts or religious contexts. We're fighting about a certain issue, and really when you come right down to it and analyze the practical difference it would make, that's not really the issue. The issue is this other thing. And so that, he thinks, is very common. The pragmatist principle can help you identify what the real issue is that you ought to be talking about. Well, Peirce starts out as a follower of Hegel. And indeed, throughout the 19th century, all over the United States, in large cities and small towns, Hegel societies sprang up, and people began reading the works of Hegel and discussing them in these small social groups, these book clubs basically devoted to the works of Hegel. Now, from our point of view today, that seems like a bizarre thing. For one thing, we have book clubs, but they don't tend to address philosophical works, especially long, serious philosophical works like the phenomenology of spirit. But also, Hegel is a notoriously difficult philosopher. So why were people so devoted to this? And how did that turn into pragmatism? Well, Hegel had, in a way, a dramatically new idea. This new idea was that absolute truth isn't there before us to be discovered in the world right now. It is the end of a long dynamic process. And so there are these higher level dynamic laws, like the thesis, antithesis, synthesis law, but also like other laws that are going to operate on the development of thought, and that we are on a ride toward the achievement of absolute knowledge, where Geist, where the spirit, where mind, ultimately and fully realizes itself. It's an inspiring picture. It fits in with the 19th century's conception of itself as an age of progress. Hegel is essentially saying, yes, the entire history of the human race, the human species, is a story of progress. Thought getting closer and closer to absolute knowledge and absolute truth. And so there's a way in which it had a strong appeal for the American spirit. It also was something that seemed to promise a new way of thinking about philosophical problems and practical problems together, because they were all bound up together. The way we think about everything is something that is part of the development of this spirit. And then how we act, that's all a result of the way we're thinking about things. And so it's all driven by these dynamic processes. The idea of progress, of dynamics, of moving forward in this way was tremendously exciting to people. Peirce is deeply influenced by all of this, but he makes two major changes to Hegel's scheme. First of all, he replaces these perhaps mysterious dynamic principles, like that one involving thesis, antithesis, synthesis, with an empirically grounded account of scientific inquiry. So he says, wait a minute, how does thought progress? Well, insofar as it's rational, I'll tell you how it progresses. It's not through mystical laws that have to be discovered through this very complicated process. It's scientific method. Scientific method is the way we have of actually advancing knowledge, so we don't have to do our own independent philosophizing. We can look at what scientists do. Remember, he was trained as a scientist. Secondly, he says, we use the idea of the limit of inquiry, not just as a hope and something we believe we're progressing toward, but as a definition of truth itself. Those are important changes, and they make pragmatism quite distinctive. It remains a version of idealism, but a really distinctive version of idealism. So here's how we think about it. Thought, as we ordinarily conceive it, aims at truth. Now, not all thinking does. Sometimes we're just musing, contemplating. Sometimes we're telling stories, imagining things. But when we're serious, in a scientific spirit or in the spirit of inquiry in general, we want to find out what's true. So truth is the goal of thinking, at least thinking of that kind. Well, the same thing is true of practice. We want to base what we do on a real conception of the world. We want to get things right. If I am walking over to the edge of a cliff, I want to be sure I know where it is. I don't want to fall off. So I want that action to be based on thinking that is actually accurate about the world. Well, what kind of thought and practice aims at the truth? Not all thought and practice does, but some does. And the paradigm of doing that is science. Scientific inquiry aims at truth. In particular, scientific inquiry aims at what we might call stable belief. That is to say, belief we're not going to have to give up in the face of further information. Our reasoning is typically what computer scientists today call non-monotonic. That is to say, it doesn't always progress in the same direction. It is not always a question of progressing, getting more and more theorems derived from our axioms. If you think about Euclid's geometry or something like that as the model of knowledge, which is something that philosophers did for centuries. Aristotle has something like that conception, so does Descartes, so does Spinoza. And if you think of knowledge as like that, well, it really is like you identify the correct starting points, and then you just keep building truths on those, and the realm of truth just gets bigger and bigger. But Peirce says, well, that's not the way science goes. In science, we frame hypotheses, then we experiment, we test those hypotheses, and sometimes they're confirmed, sometimes they're rejected, sometimes we have to make adjustments and try again with a new and better hypothesis. And so we often give up beliefs in science in the face of further information. In fact, these days it's popular for some people to say, well, the science is settled about X, Y, or Z. Peirce would say the science is never settled. Science, no matter how well supported something is always open to the possibility that we're wrong about it. It's our best hypothesis. At the moment, our evidence seems to support it. But even in such a case, he says, there is a real possibility that it will have to be given up in the face of further information. Our goal, of course, is to come to belief that, as it happens, though they in principle could be overcome by further evidence, they never really will be. All the subsequent evidence will either support them or at least not contradict them. So what we're doing in science is proposing hypotheses, testing them, developing them, and trying to get them into a form where we no longer have to keep revising them or getting rid of them and replacing them, where we can instead say, well, this was our hypothesis. So far it's worked and it seems to keep working. And our hope is it'll keep working on into the future. So call a belief stable when it really will, when it will continue. In principle, yes, it could be overturned, but in practice, in fact, it won't be. That makes it a stable belief. Well, that's the goal of science. So what is special about science and about scientific method? It's self-correcting. We make these observations, we formulate hypotheses, we test their consequences by experiment, then we revise the hypotheses in light of new evidence. We're looking for stable ones that we won't have to revise anymore, but hey, along the way, how do we have any confidence in the hypotheses we're making and in what's survived tests so far? Because we've been doing this. We've been making hypotheses, we've been making observations, we test consequences by experiment, we revise our hypotheses, we keep going. And so science is self-correcting. Now, sometimes the correction happens quickly. Sometimes it can take centuries before people realize, yes, this idea is wrong-headed, we have to formulate a new hypothesis. But that's partly because as science improves, it gets harder and harder to actually find cases that are really going to divide some scientific theories from others. And so often people are in a position where they say, look, we can't solve this without, tremendous technological improvements like building a super collider or sending an explorer beyond the solar system or doing a variety of other things that are going to give us new kinds of evidence that will enable us to test theories in new ways. So what gives us confidence in the scientific method is that it's self-correcting. And Peirce says, look, that's really a very special and very important quality to scientific method. It's not something you find in other inquiries. Is art self-correcting? You might hope so, in that art that's really bad doesn't sell, and so people can't make a living at it, and they go out they have to do something else, and so on. But really, there's nothing like this process in the art world or in the world of literature or the world of music or other things. There's something maybe kind of approximating it. But science is unique in that it does make these observations, formulate the hypotheses, and then keep revising them whenever problems are encountered. So here we see some examples of experiments. Here, a very disturbing one of seeing what happens to a bird when we pump all the air out of a chamber containing it. As you can tell by the worried faces of the children, it's not going to be good. Or here, a dramatic experiment. The man who is being shot at right there invented the bulletproof vest. And here is how he tested it. He was so confident that it would work that his way of publicizing it was to get photographers there, get, yes, the police there, but also get various people who were journalists there to watch him being shot in the chest while he wore the bulletproof vest to prove that it worked and that he would survive. He did. People have admired Albert Einstein partly because of his attitude about science. Lots of scientists get pretty attached to their theories, and sometimes it takes somebody else to actually test a hypothesis and find the experimental evidence that it needs to be revised or rejected. But Einstein was open to that from the very beginning. Our goal, Peirce would say, is to formulate laws and theories that survive experimental tests. And that's the way Einstein thought of his own theories. He said, look, there's this puzzle about the nature of time, about the speed of light. I don't know how to make sense of the Michelson-Morley experiment and a variety of other phenomena that by the turn of the century, physicists were aware of but had no explanation of. So he formulated first the special theory of relativity and then the general theory of relativity to try to solve those problems. But his reaction to that wasn't to say, so here's the truth. It was instead to say, these are hypotheses. And where exactly is my theory going to differ from Newtonian theory or maybe other competing theories? Well, he proposed some experimental tests. And he said, here is what's going to test. If I don't turn out to have the right predictions about these cases, get rid of my theory and replace it with something better. So in 1905, he published the special theory of relativity. According to that theory, length, velocity, simultaneity, and so on are relative to an inertial frame. They're not absolute or primary qualities, as philosophers had tended to think. They're relative to the perceiver. And then in 1915, he proposed the general theory of relativity. According to that, space-time curves around masses. There is no action at a distance. There is no force like the force of gravitation, as in Newtonian theory. Instead, space-time itself gets curved around massive objects, and that gives the effect of a gravitational force. So in Newton's theory, gravity works something like this. We've got the law of gravitation that says the gravitational force is proportional to the gravitational constant times the product of the masses of the object divided by the square of the distance between them. In Einstein's theory, we get a picture like this. The actual equations are incredibly complicated, involve the tensor calculus, but the effect of it is that space-time has a curvature. And that's why the moon revolves around the Earth, because space-time is curved around a massive object like the Earth. Well, here are the classical texts that Einstein proposed: the perihelion precession of Mercury, the deflection of light by the sun, and gravitational redshift of light. He says, let's find out if we can observe these. My theory predicts them. Newton's doesn't. Here's a good test case. Let's measure carefully and see if we predict this. And of course, there's a possibility. Maybe Newton will turn out to be right. Maybe Einstein's prediction will be right. Maybe neither will be right, and we'll have to say we need yet another theory. Well, people did that, and in 1919, they came back with the report that Einstein's theory was correct. So you can see here some things in the popular press. It really took the public imagination. Is there a fourth dimension? Einstein's theory has given a tremendous jolt to the world of science. Here is the key paper by Arthur Eddington of Two Tables fame, who went to the Indian Ocean to do the measurements and came back reporting on the results of the expedition, which were to confirm Einstein's theory about the deflection of light in the sun's gravitational field. By observing the total eclipse of May 29, 1919, that again revolutionized the scientific world, and Paul Johnson, the historian, in his book Modern Times, says this is really the beginning of the 20th century. Here, another newspaper headline, how Dr. Einstein has modified our ideas of nature. To the general public, it is startling to learn that life doesn't travel in a straight line. And then Einstein theory causes scientific war. The little highlighted passage there, which you probably can't read on your screen, says this: "This should have ended a pleasant evening. But after the meeting, a number of students chased Professor Einstein home and threatened to cut his throat." Well, yes. It was something that stirred a great deal of passion, positive and negative. It was something that did revolutionize people's conceptions of the universe and their place in the universe. And so the theory of relativity was something that was profoundly shocking to people, making major newspaper headlines, causing students to riot and chase him, threatening to cut his throat in a way that is a little hard for us to imagine these days. One doesn't think anybody's going to read something in physics letters A, for example, and suddenly start charging through the streets rioting or writing massive newspaper articles about it for the popular press. In any case, the pragmatist says Einstein's attitude is exactly the scientific ideal. We formulate these hypotheses, and then we subject them to test. We hope they'll survive the test, but we face the fact they very well may not. Well, this leads to a revision in our conception of the relationship between science and truth, or at least so argues the pragmatist. The correspondence theorist defines scientific activity as the activity that aims at the truth. And so far, I've been talking about it in that kind of common-sensey way, a way popular among realists in philosophy that says truth is correspondence with the facts. Peirce turns that around. He says, let's instead define truth as that at which scientific activity aims. So instead of saying what makes something science, it's aiming at truth. Instead we say, what is truth? It's not correspondence with reality, as if we could somehow step outside of science, step outside of our own minds, our own language, our own conceptual scheme, and grasp reality and judge a correspondence between our statement and the fact. He says, no, truth is defined as what science aims at, namely stable belief. So truth becomes a belief that is not going to be overturned in the face of further information, further experimentation, further testing. So Peirce puts it this way: the opinion that is fated to be ultimately agreed to by all who investigate is what we mean by the truth, and the object represented in this opinion is the real. Reality is just being something that is part of and has its existence claimed by our ultimate theory that people agree on. And the opinion that's fated to be agreed to by everyone, because it is stable belief, it will never be overturned, that is simply the truth. That is what truth is. So truth, according to Peirce, is a kind of coherence. He calls it a concordance with not just what we know now, but with the ideal limit of scientific inquiry. Not what even scientists will know tomorrow or the day after, but the ultimate limit. If we were able to carry out all experiments, subject all of the hypotheses to tests, we'd end up believing this. He says that's the truth. That's what it is for something to be true. The truth is simply what we're all eventually bound to agree on. Well, as I've stressed throughout, Peirce thinks that anything in principle could be overturned. He's a fallibilist. He thinks any of our beliefs might turn out to be mistaken. Any of our hypotheses might turn out to get contrary evidence when we inquire. So further inquiry is always something that could lead us to give up any of our beliefs. Beliefs can be justified and can arise from a reliable process, but still be fallible. That means new evidence, new arguments, counterexamples, and so on might end up undercutting those beliefs. So he says we can have knowledge in the sense that we can form beliefs that have good evidence behind them, for which we have justification, that have arisen from a reliable process, that so far have not been overturned by any further evidence. But we can never have certainty. We can never have certainty about anything, because it is always possible that further inquiry will develop something that surprises us. And so we will face new evidence that forces us to give up that belief. Well, that allows Peirce to undermine some of Leibniz's arguments for rationalism. Remember, Leibniz argued that contingent experience doesn't entail any necessary truths, and particular experience doesn't entail any universal truths. Peirce is going to say, well, that's okay. Nothing has to be entailed. It doesn't have to be forced to be true on the basis of our experience. It just has to be supported by our experience. It has to be something that can explain our experience, and it hasn't yet been overturned. So he says, look, evidence never conclusively establishes a conclusion. Leibniz wants too much. He wants something that can serve as a universal and necessary synthetic a priori principle to get us from the contingent particular experiences to these universal, necessary, law-like conclusions. He says that's not how it works. We propose those necessary, universal, law-like things as a way of explaining our experience, but there's always a gap. There's always fallibility. These are never guaranteed. We're in a position where we always might have to give them up. The best we can hope for is stability, that we won't, in fact, have to give them up, that further evidence is going to end up confirming them, supporting them, rather than undermining them. Well, here's how we should think of science then, and in general human inquiry. It's a process of rational belief revision. We encounter new information. We update our beliefs. We keep some of them. We reject others. We add new ones. We revise some. Truth is what works in the context of that rational belief revision. Sometimes people summarize pragmatism by saying the truth is just what works. Well, yes, but in this very special sense. What continues to work in the context of our attempt to revise our beliefs rationally. It's not like, hey, I wasn't sure what to do about that fence that's falling down in the backyard, but I did this and it seemed to work, so I guess everything I thought about it was true. No, it's not like that. It's like, look, we're doing the process of science, we're engaged in this self-correcting form of inquiry, and what works in the context of that we can call the truth. So truth is what our process of rational belief revision stabilizes on. Truth is something that we end up agreeing to, he says, when we engage in this self-correcting process of rational belief revision. We end up with some stable beliefs, and that's what counts as the truth.